Next, let's look at finding the indefinite integral of x e to the minus x dx. First off, I want to remind you that we do not have an integration formula for when you're multiplying two functions inside your integrand. It's a common mistake to think that if I want the integral of f times g, I can just do the integral of f times the integral of g. Unfortunately, that is not the case. And we don't have something like a reliable product rule either. So what you typically do first is check to see if a U substitution will work, because that's the easiest of all our integration techniques. But you can try that here, but it won't work. So then the next thing to try is integration by parts. And I'll just remind you of the integration by parts formula. It says the integral of u dv is uv minus the integral of v du. So we have to start out by deciding what is our u going to be and what is our dv going to be. Now when we use the v, notice that we're going to have to get from dv to v, because our formula includes not dv but v. In other words, we're going to have to integrate our dv. So we need that to be something we can integrate, and ideally it shouldn't be something that makes the problem more complicated. So I'm probably not going to use x for my dv, because then v would be 1/2 x squared, which is more complicated. So I'm thinking that the x is going to be my u, and the dv then has to be everything else. So the dv has to be e to the minus x dx. Now from there, we need to know what du is to put into our formula right here. And I also need, as we just said a minute ago, to know what v is. So let's start with the du. That's easier. Du will just be dx. But what about v? V is the antiderivative of e to the minus x dx. So let's figure that out. I'm going to go over to scratch paper to do this. Just pretend this little corner is scratch paper. V is the antiderivative of e to the minus x dx. I'm going to need to do a little u substitution. Let's let u be minus x, then du will be minus dx. So I'll be putting minus du in for dx, which gives me integral of e to the u times minus, I'll make that a -1, times du. So all our x's have been replaced by u's. That minus sign can come out front, and the antiderivative of e to the u du is just e to the u. And what u really was our name for minus x. So I have minus e to the minus x. That is my v. Now when you're doing integration problems that someone's going to read, in other words, that someone's going to grade, you do definitely want to give the outline of what you're putting in. Don't just throw things in over here without having explained them over here. That said, grungy things like this can go off on scratch paper. Okay, anyway, so now using our integration by parts formula, I'm going to have uv, I'm just using the formula here, uv is, oh, and sorry, I was talking and writing at the same time, and I say I made one mistake over where the v is, over here where the v is. I wonder if you see the mistake. We're not supposed to have a dx here because it's not v dx or it's not dv, so no dx there, and that's why there was no dx down on my scratch paper either. Okay, so back to using the formula. uv is x, that's our u. V is minus e to the minus x, so that's our uv, and then we have minus the integral of v being minus e to the minus x, let's see, v du, and our du is just dx. Cleaning up this first term a bit, I'm going to bring that minus sign out front and get minus x e to the minus x, and then for our second term, those two minuses cancel, so I'll have plus integral of e to the minus x dx. But you know what? We just did that over on our scratch paper. And we got minus e to the minus x. And this time I will put a plus c because we're not putting in limits of integration. We're just finding the general antiderivative. Let me remind you that there's something you can always do to check your answers when you've done an integration problem, because finding antiderivatives is much more complicated than finding derivatives, and it's helpful to know that you can check them, your answers. So the way to check is to see that if I were to differentiate this back down, remember differentiation and integration are opposite operations. If I were to differentiate that, would I get back to where I started? Well, let's see. Using the product rule on minus x e to the minus x, I'll have minus 1 e to the minus x, and then minus x times e to the minus x times negative 1, using the chain rule there. And then I have minus e to the minus x times negative 1 using the chain rule. The derivative of any constant is 0. So let's see, I get minus e to the minus x. In the second term, the two negatives cancel. So I have minus and a minus. So that's going to give me plus x e to the minus x. Again, in the last term, the negatives cancel. I've got a minus and a minus. So I have a plus e to the minus x. The e to the minus x's cancel each other out and leave me just x e to the minus x. And that's what I wanted to see. That lets me know that, yes, indeed, the thing I got is the antiderivative of x e to the minus x, because when I differentiate it, I get x e to the minus x.